Okay, this section here, we're going to be looking at the real roots of quadratic functions. So as you saw in the previous sections that we've been seeing from the quadratic equation, ax squared plus bx plus c equals 0. So whenever you're solving, you always have to make sure that your equation is equal to 0, okay, like it is here. And from the quadratic formula, we have two x values. So there's x1 equals negative b plus the square root of b squared minus 4ac divided by 2a. And then there's x2 equals negative b minus square root of b squared minus 4ac divided by 2a. So there are always two roots. But if you take a look at the graph here, the other word for roots is x-intercepts. And we've seen that in class. We've talked about that several times. If you look at the graph, it shows that it does not intersect the x-axis. So here's your x-axis, and this graph does not touch the x-axis at all. So could you solve the quadratic equation? What happens when you do solve the quadratic equation, either by factoring or by using quadratic formula? And it's asking, does every quadratic equation have a solution? So we're going to take a look at examples that are going to answer these questions, and we'll see what happens. Before we start looking at the examples, you have to know the definition of discriminant. Now, the discriminant is the value of b squared minus 4ac. That comes from the quadratic formula. So if you take a look at the quadratic formula, which is right up here, we see the part of b squared minus 4ac. But for the discriminant, we don't take the square root. We just look at the b squared minus 4ac value. So you take your a, b, and c value from your equation, and you go ahead and substitute that a, b, and c value to find the discriminant. So we're going to do examples of that, and you'll see what the heck that's used for. The discriminant is determined from the coefficient of the quadratic equation. So that means your a, your b, and your c values are taken from your equation. That's given. And it determines the number of real roots that a quadratic equation has without having to do your factoring, without having to use the quadratic formula. So if the question says how many roots are there, you don't need to solve the entire thing. All you need to do is find the discriminant. Alright, so here it says determine how many real roots each equation has. So if we want to just determine how many roots there are, we're going to use the discriminant. Okay, pardon the writing on here, it's a little bit messy. But we're going to go ahead and use the discriminant. And from the previous equation, the discriminant formula is d, capital D, equals b squared minus 4ac. My a value is the value in front of the x squared, which is 1. My b value is also 1, that's the number in front of my x. And my c value is negative 2. So you're going to substitute those values using brackets. So we have 1 squared minus 4 bracket 1, and my c, which is negative 2. I have to follow BEDMAS at all times. 1 times 1 is 1. Negative 4 times 1 is negative 4. And negative 4 times negative 2 is positive 8. So that means that the discriminant is equal to 9. Since d, the discriminant, is positive. Oops. So since d is positive, the equation has two real roots. So this you have to kind of know. This means that you'll be able to continue the quadratic formula and do the square root of 9 and continue your calculations. So when the discriminant is positive, the equation has two real roots. Now we have to go ahead and solve by graphing. I'm going to rewrite this equation on another page. So we've got x squared plus x minus 2 equals 0. And I'm just going to make my chart here for this equation. It says to solve. So method 1 to solve, you can graph this and take a look at where your x-intercepts are. So we're going to go and find this table of values for the x values of negative 2, negative 1, 0, 1, and 2. So to find the y values, we just substitute the x's. So I'm going to do negative 2 first. And when I go ahead and sub that in, I get an answer. This shouldn't be 0, this should be a y. I get 4 minus 2 minus 2, and I get a y value of 0. When I go ahead and sub in -1, -1 times -1 is +1. 1 minus 1 is 0, and 0 minus 2 is -2. So you can go ahead and continue this work, but I'm just going to go ahead and sub in the values for 0, the ones that are in the textbook. So I would like you to calculate these in your notebook to make sure that you have them. So an x-intercept is when it crosses the x-axis. So if you can picture this, if you graph this, -2, 0 is right over here. Oops. -2, 0 is right here. -1, -2 is approximately here. 0, -2. 1, 0. And 2, 4 is approximately up here. So you can tell the general shape of this parabola is going to be like this. And right here, you can tell what the zeros are, or another word for zeros would be the roots. So you can solve this by graphing. I suggest that you take a look at the textbook just so that it can help you a little bit. I'm on page 146. So you can tell that the zeros are -2, 0 and 1, 0. So you would write an equation. The zeros are -2, 0 and 1, 0. You can also write it as x1 equals -2 and x2 equals 1. It's just important to have a concluding sentence. Method 2 would be solving by factoring. If you can solve by factoring, you might as well try it. So here we know that this is not a perfect square trinomial since -2 does not have a square root. So we're going to try doing factoring by decomposition. So 1 times -2 equals -2, and my b value is +1. The only factors of 2 is 2 times 1. Now since the AC is negative, I have to have a negative and a positive. We have to make this equal to 1 somehow. So I'm going to make my 2 positive and my 1 negative, and that's going to work since 2 times -1 is -2, and 2 minus 1 is 1. So my two numbers are 2 and -1. Since my a value is 1, I can go ahead and open up two brackets, make sure to put this equal to 0, and write that it's x plus 2 and x minus 1. This is factoring. We still haven't solved. So what we're going to do is put x plus 2 equal to 0 and set x minus 1 equal to 0. To cancel out my positive 2, I'm going to have to subtract 2 on each side, which means that my x is going to be equal to -2. That's my x1. I'm going to do the same thing on this other equation. Instead of, to take away -1, we're going to add 1 on both sides. And that means that I'm going to have x2 equals +1. So it's important for you to remember how to solve since we're at this point. And then you would just write a concluding sentence again. My two zeros are -2, 0, and 1, 0. So there are two ways to solve. You can choose the only method that you prefer, unless I specifically ask to solve by graphing or to solve by factoring. Now, before you even start this equation for question B, you have to make sure that your equation is written in standard form. And standard form is ax squared plus bx plus c equals 0. This equation is not equal to 0, so we need to do some work before we even start. I'm going to go ahead and cancel out this -4 by adding 4 on each side. And you'll see that when I do that, I'm going to end up with an equation equal to 0. Now that it's equal to 0, I can go ahead and determine how many roots I have. So to determine how many roots we have, we're going to go ahead and calculate the discriminant. So the discriminant is capital D equals b squared minus 4ac. The b value is negative 4. The a value is 1. And the c value is positive 4. So you cannot do this equation if your equation is not in standard form. If it's not equal to 0, you have to make sure you do those calculations before you start your work. So I'm just going to continue this. Negative 4 times 1 is negative 4. Negative 4 times 4 is negative 16. And here I have negative 20. Since my discriminant is negative, so I'm going to show you write this down. So since the discriminant is negative, there are no real roots. Because if you complete the quadratic formula and you try to do the square root of a negative number, it's not going to let you. So you're stuck at that point when you try to solve this using quadratic formula. That's why there are no zeros. But if you take a look at the graphing, so we're going to go ahead and graph this. Just going to rewrite the equation here. So x squared minus 4x plus 4 equals y. I'm going to write down my x's that we always use, negative 2, negative 1, 0, 1, 2. And I'll do the work for one of them. And then you're expected to do it for the rest of them. Negative 2 times negative 2 is positive 4. Negative 4 times negative 2 is positive 8. 4 plus 8 is 12, and 12 plus 4 is 16. So again, I expect you to do the work for this. Once you do the work, you'll see that at negative 1, it's 9. At 0, it's 4. At 1, it's 1. And at 2, it's 0. So here, you can see from the graph that the x-intercept, if you go ahead and you do a quick sketch, negative 2, 16 is way up here. Negative 1, 9 is here. 0, 4. And then 2, 0 is right here. So it's going to look something like this according to the symmetrical properties. Now I made a mistake here. If I go back, just going to take a look at this equation again for the discriminant. We have b squared equals b minus 4ac, sorry. I forgot to square. I'm going to put it in a different color. So you're going to see that, yep, I made a mistake. I forgot the squared right over here, which is going to change this answer. And it's going to change all of my other answer. What I said wasn't false, but the calculations weren't done properly. So I'm just going to go ahead and erase this part and recalculate it in red so I can change it. So make sure you go back and change it. I apologize, I'm human, I make mistakes. Negative 4 times negative 4 is positive 16. Negative 4 times 1 is negative 4. And negative 4 times 4 is negative 16. And 16 minus 16 is 0. So that's where the difference is. You'll see from the graph, and this is why I knew there was a mistake, there is a 0. It's sitting on the coordinate negative 2, 0. So there's a 0 at negative 2, 0. This means that there are 2 zeros at positive 2, sorry. So there are 2 zeros at positive 2. It's the same one, but there are still 2 since this is a parabola. So I'm going to go back and write since the discriminant is equal to 0, there is only one root. There is only one real root. Okay? So you can see there's one real root or two roots that are the same. I accept both answers. Our graph is still fine. Okay, so here's the 0. The zeros of this function are negative 2, 0 twice. So it's happening twice. This is a little bit confusing, but when the parabola sits on the x-axis, there's really only 1 0 or 2 that are the same. And again, I know I'm repeating myself, but it might actually help. We're going to go ahead and solve this one by factoring. So we have x squared minus 4x plus 4. When you're factoring or solving, excuse me, you need to make sure your equation is equal to 0. So if we're going to try to factor, we're going to do the ACB method. 1 times 4 is equal to 4, and my b value is negative 4. Whoops. Okay. So the factors of 4 would be 2 times 2 or 4 times 1. We need negative 4, so negative 2 minus 2 works, but that means I have to add 2 negatives here and make sure that it works. Negative 2 times negative 2 gives me positive 4, and negative 2 minus 2 equals negative 4, so that works. My two numbers are negative 2 and negative 2. Now since my a value is 1, I can go ahead and open up two brackets and put x minus 2 and x minus 2. Essentially, this is a perfect square trinomial, so you could have factored it by perfect square trinomial. Since it's the same bracket, all we need to do is write x minus 2 equals 0 once, and we're going to go ahead and solve by adding 2 on both sides, which means that x equals positive 2. There's only one 0, so the 0 is x equals 2. And this is the concluding sentence that I'm looking for. Another type of example that you're going to be asked is to find the x-intercepts. For question A, you're going to need to round your answer to the nearest hundredths when necessary. So the x-intercept is the same thing as finding the roots of an equation or finding the solution. Okay? So all those things mean the same, and you need to make sure that you can tell the difference between all of them. So what we're going to go ahead and do is we're going to set y equals 0, because we're looking for the x-intercepts. That means we have to set y equal to 0. You need to make sure that you write that down before you start any of your work. So I've written it down here, and you're going to go ahead and use the quadratic formula. So your a value is 2, your b value is negative 1, and your c value is negative 4. Now you could try the method of ACB, if you prefer, which would be 2 times negative 4, and b equals negative 1. Factors of negative 8 are 8 times 1 and 4 times 2. None of these options allow us to add or subtract to make negative 1. So none of these work, which means we need to use quadratic formula since we cannot factor. You cannot write that this cannot be factored, therefore there are no solutions. You don't know that until you do the quadratic formula. So we're going to go ahead and do the quadratic formula on the next page. So we have 0 equals 2x squared minus x minus 4. The quadratic formula is x equals negative b plus or minus b squared minus 4ac, all that divided by 2a. So we're going to have negative minus 1, my a equals 2, my b equals negative 1, and my c equals negative 4. So this is why I put my negative 1 in brackets, since 2 negatives is going to give me a positive in the next line. Then I do plus or minus square root of negative 1 squared. Don't forget to leave that in a bracket, since negative 1 times negative 1 is positive 1. My a value is 2, and my c value is negative 4. All that is going to be divided by 2 times 2. So here I have positive 1. Negative 1 times negative 1 is 1. Negative 4 times 2 is negative 8. Negative 8 times negative 4 is positive 32. And all this is going to be divided by 4. The square root of 1 plus 32 is square root of 33. And all that is divided by 8. So I'm going to go ahead and split these two roots up. I have 1 plus square root of 33 divided by 8. and I have x2 equals 1 minus square root of 33 over 8. So when I go ahead and do that, I get an approximate value. On your calculator, you would do 1 plus square root of 33 equals, then divided by 8. Why 8? Let me go back here. It should be 4, divided by 4. Now, some of you guys may have been really confused, and I apologize for that. It's actually divided by 4. So when I rewrote it, I was having some issues. So when I do my calculation, I have approximately 1.69. You have to round it to the nearest hundredth, which is 2 decimals. And I have x2, which equals to approximately negative 1.19. So all we need to do here is say, therefore, the x-intercepts are x1 equals 1.69 approximately, and x2 equals approximately negative 1.19. If you were to look at the discriminant here, which is 33, the discriminant is equal to 33. It's the part of my quadratic formula that's inside the square root. So you notice how it's positive, which means there are 2 real roots. And here we found the answers of x1 equals 1.69 and x2 equals negative 1.19. So it's important for you to verify this by putting it in the graphing calculator and to check with your discriminant. We're going to go ahead and do question B. All right, for example B, we have to find the same thing as the x-intercepts. So we're just going to label our A value, our B value, and our C value. Before you start using the quadratic formula, you want to make sure that you can maybe not factor this. So we're just going to take a look at our AC, which is equal to 6, and our B value, which is negative 4. So the factors of 6 would be 6 times 1, or 3 times 2. None of these, again, work to make negative 4. You can't rearrange any of these numbers to make negative 4. So you cannot use ACB, which means that you are going to use the quadratic formula. So we're going to write it down, negative b plus or minus square root of b squared minus 4ac divided by 2a. Sub in your values. Now make sure again that you're careful with this negative 4 value. You have to put it in brackets at the front and inside your square root. Your a value is 3 and your c value is 2. You're going to divide that by 2a. Again, if I'm going too fast, just make sure that you pause this and copy it as I go. So negative times a negative is positive 4, plus or minus, negative 4 times negative 4 is positive 16, negative 4 times 3 is negative 12, negative 12 times 2 is negative 24. All of this is going to be over 6. Now I'm going to rewrite this on the other page. So we have x equals 4 plus or minus 16 minus 24, all this over 6. So if I continue, I'm just going to calculate inside the square root, and 16 minus 24 is negative 8. Now there's a problem here, because if you go to do the square root of a negative number, it's not going to work. So your discriminant is the part that's inside your square root, is negative. And since it's negative, there are no solutions. There's no way you can keep going here. It's impossible. So there are no solution since there is a negative square root. So it's very important for you to write the reason why and why you can't keep going. So now you're expected to write the key concepts that are on page 149. Just to go over it real quick, it says if d is equal to 0, that means there is only one real root. If the discriminant is positive or greater than 0, there are 2 real roots because you can continue your formula. If the discriminant is less than 0, that means there are no real roots because you cannot continue the quadratic formula. So essentially, this is the important part of the key concepts, but make sure that you copy the graphs and the rest of them.